I'm going to use the student survey data, the expanded student data set, which has over 600 heights. I'm going to look at the height variable again, and I'm going to look at means and standard errors. When you're reporting the statistics of a data set, when you're reporting the statistics and a summary of any scalar, any measurement variable, then what you should report is the mean and not the standard deviation. You should report the mean and the standard error. The reason for this is the standard deviation tells you about the variability within that particular data set. But another researcher who gets your set of data and finds your mean or your particular value, what they're interested in is when they collect their own sample or do their own repeat of your experiment and they get a number, their number will not be exactly the same as yours. But they want to know, is it so different that it couldn't be from the same experimental setup? Are the differences so large that there's a discrepancy between the two different experiments? So in that case, you want to find out what's called the standard error of the mean. This tells you about the variability of means between different repeats of the experiment and between different samples. Now, SPSS does this very simply. It's in the Explorer part of the dataset. So actually, if I take a step backwards, I go to Analyze, Descriptive Statistics and Explore, and I just want to put height into the dependent list, and then I just want to calculate the statistics because I just want the table of statistics, and I go OK. So the top thing that is calculated is the mean, which is 1.6666585, and here is the standard error. Because of the size of the data set, this standard error, so that is in, the measurement is in meters, 1.66 meters. So this 0 represents centimeters. So this is telling you that the standard error is half a centimeter. So if somebody else was to collect a data set, they would expect their data set to be within half a centimeter, their mean of their data set to be within half a centimeter of this value. Any discrepancies beyond that become unexpected, and more than 1 or 2 centimeters beyond that become very rare events indeed.